Hello, this is instructor Rick Powers for Western Technical College, Basic Statistics. Lesson 19, the normal distribution, part 1. One of the most important contributions of statistics to our understanding of the world is found in a game on The Price is Right called Plinko. What is Plinko? Plinko is a game where a person drops a disc into a chute, which then has a number of pegs that make the disc bounce to the left or to the right. The disc ends up in a slot at the bottom. Wherever the disc lands, there's a prize amount given. How is this important to statistics? Well, we can think of the slots at the bottom as representing a histogram. And the pegs, which make the disc bounce, are random events that change the data. Sometimes data values are made to be higher and sometimes lower, but where do we expect most of them to be? There are many situations, similar to Plinko, where we expect that the data will end up towards the middle. In fact, it turns out that the Plinko process is like having a binomial distribution. There are random events with consistent probability. Mathematically, then, we can ask the question, what happens to the binomial distribution as the number of events gets large? We've already answered that question. The binomial distribution becomes bell-shaped when n is large enough. So the binomial distribution, which is based on the mathematics of probability, will lead us to understand the behavior of data sets that have most of the data in the middle. Here's a video on YouTube that shows the process with bouncing balls. You see the link there. Here's another good explanation, another link there, and these links are also available on Blackboard. There's a complicated formula that describes the graph of the bell-shaped curve, but we really don't need it. Recall that our focus is on knowing what to expect, which then requires us to know how much data is in specific parts of the curve. What's really helpful at this point is to become familiar with the technology. Computer programming allows us to get the probability for any section of the normal curve that we want. However, there are some statistical traditions and definitions that are used in the situation. First of all, we create an artificial data set which has a mean of 0 and a standard deviation of 1. This is called the standard normal distribution. Since the mean is 0, then the variable has positive and negative values. Here's the graph. 0 in the middle. Goes down to -3, goes up to +3, and it even extends beyond that. The numbers on the horizontal scale for this distribution have a special name, z-scores. We will come back to the definition later. For right now, let's consider what the technology will tell us about them. As mentioned earlier, our main concern is finding the amount of data for specific parts of the data set. There are 3 ways of describing the amount of data: the percent of the data, the probability, and the area under the curve. Example, how much of the data is found above a z-score of 2? Or what percent of the data is above 2? We could write this in terms of probability. Probability that z is greater than 2. Note, we could have an equal sign to have z greater than or equal to 2, but that would be like measuring the area of a straight line, which is actually 0, so it doesn't matter. In mathematical terms, we could also say, what is the area under the curve for z greater than 2? No matter how we say it, we use technology to find the answer. The textbook might tell you about using a table, but that's a relic of the past. We need to look at the right tail of the curve using the correct buttons for the software, and then we will have this result. The probability that z is greater than 2 is approximately 0.023. You can see the graph there, the red section shaded in. And you see down below, this particular type of software shows the mean of 0, standard deviation of 1, probability that, in this case, x greater than 2 is equal to that number. Another important process requires to find z-scores when we're given percentages. Example, what z-score will be used to find the lowest 4% of a data set? Again, we need to use technology for this. One way to state the problem would be find the z-score, let's call it z1, so that the probability that z is less than z1 is equal to 0.04. Here's the result from technology. The z-score for the bottom 4% is about negative 1.75, or the probability that z is less than negative 1.75 is equal to 0.04. On the graph, you can see the shaded part. Now on the left-hand side, we have the mean set at 0, standard deviation of 1, and the probability for x less than negative 1.75, and so on, is equal to 0.04. End of lesson 19.